Okay, welcome, and thank you to Cristina Stefanelli from Unimed, which is working very hard on this training. I will give our attendees, we have 76 persons, which is a lot, by the way. Just a little context about the project. This is an Erasmus Plus capacity building project. We are working for the setting up of a master in cross-media journalism in these 4 Libyan universities, in Sirte, in Tripoli, in Zawiya, and in Misurata. Our colleagues from these universities are participating to the training. Training was expected to take place in Europe due to the situation we know, the epidemic. We split the training into 2 sessions. The in-presence one will be hosted by Sapienza, hopefully, next year. And we are at the beginning, we are in the middle of the online training. But we took the occasion of this online training for having some high-level speakers. And this is Christina's formula, this Monday's 4 pages idea. The idea of having some high-level, very qualified speakers in order to provide you, and to provide also us on the European side, the 5 European partners of the project, with some insights into some very complicated issues and scientific matters. Today, we will talk about something which is important, and I will be very clear. I have no expertise and no background in this, machine learning and artificial intelligence, and I think this is very important for us this day in order to better understand some basic information about artificial intelligence in the first speech, and then the implementation of machine learning into news production in the second speech by Charlie Beckett. A very few words to introduce our first guest. She is from our actually partner institution, Sapienza University, even though she works in another department. Tiziana Catarci. We know you are very busy, so thank you for being with us. She is a full professor in computer science and engineering, PhD in computer science, and she is, I think, the most important part of this very impressive resume. She is currently the director of this multidisciplinary Econa Research Center. She was already former director of the Design Research Center at Sapienza, and if I remember well, the former vice rector at Sapienza, which is, as you maybe know, the biggest university in Europe. Before dealing with the journalism, news side of the problem, we will have an introduction by Professor Tiziana Catarci to, I don't know, myths and realities about artificial intelligence. Everybody's talking about artificial intelligence, but maybe we should know something more about IA before talking so much about it. So thank you for coming, and we will listen to you. Tiziana, please, the floor is yours.
Hi, thank you for the invitation. I did prepare a non-technical talk, so I hope it will be understandable for everybody, in particular people without a specific background in computer science. You should see my screen.
Yes, perfectly.
Correct?
Yes.
Okay.
Yes, very clear.
Okay, do we want to try the presentation visualization? Sometimes it doesn't work, I don't know why, but we can try. Let me try it, otherwise we come back to this. Okay, no, doesn't work. Doesn't work. You never know why. So let's stay with this, sorry. let's stay with this modality. I think to work in presentation style, I need to duplicate my screen, but it will take too much time. So if it's fine for you, we stay with this presentation. Okay, I will try to talk about myths and prejudices about artificial intelligence, and in particular machine learning. That is now what is considered to be artificial intelligence, but we will start immediately from seeing that this is not the case. So first of all, basic definition. What is artificial intelligence? Artificial intelligence is simply a scientific discipline that aims at creating machines that show a behavior that would be called intelligent if seen in a human being. This is the traditional definition of artificial intelligence. Then what is also well known is that there are historically two kinds of AI. The first one, which is called general AI or large AI or horizontal AI, can handle different problems and scenarios. So the idea of the general AI is to try to really replicate the way in which humans think and solve problems. So it is horizontal because it could be applied to any problem, exactly as humans do, and is very ambitious. So in fact, we do not have yet general AI. This is just to start putting the things in place. Then there is a narrow AI. Narrow AI is what we have now in practice. Narrow AI or vertical AI is something that in a more or less intelligent way solve specific problems. So is designed to solve one problem or a category of problems, but specifically. So once you have an algorithm that solves, for instance, image recognition for certain kinds of images like human faces, then you cannot take this algorithm and put it in, assign a different goal to it. You couldn't even use the same algorithm to recognize car images. So it is specific. You have a problem and try to find a solution. Okay, now let's see that AI is around since many years. It's not new. There is nothing new, actually, in what we have now. In 1953, these are proceedings of an English conference. This is Ada Byron, the Countess of Lovelace, one of the most preeminent scientists in computer science. She was much before the 1953. But let's see what was written in the introduction of these proceedings. I will read it because it's very interesting. It seems probable that we shall have a second industrial revolution on our hands before long. The first one, that is the well-known industrial revolution of the past century, replaced men's muscles by machines. And every worker in England now has an average of more than 3 horsepower to help him. In the next revolution, machines may replace men's brains and relieve them of much of the drudgery and boredom which is now the lot of so many white-collar workers. No one has yet proposed a unit in which to measure brain power, so one cannot express in numerical terms the help which the next generation of clerks may expect to receive from machines. Okay, we are now, in this very moment, exactly in the second revolution, the digital revolution. We are living it every day. And indeed, a lot of boring works have been already replaced by machines. You can see, for instance, in the banks, there are much less clerks and more intelligence machines. And in all places in which the kind of work is a repetitive one. Repetitive works will disappear in some years. But we will have a lot of new works, new kinds of work, and new kinds of jobs, and we will never, at least never in our temporal horizon, replace the creative work of humans. So, which is the AI dream? From Turing onwards, the AI dream has been to build an intelligent machine. If some of you is old enough to recognize, like myself, to recognize HAL, the computer of the famous movie. This is the HAL. HAL was an artifact with which you could interact as if it was a human being. We do not have HAL yet, and we do not know today if it will be possible ever to have a machine like this. So the AI dream is still a dream as of today. This was the Turing dream, more or less 100 years ago. And we are still in the identical situation, again, more or less. In these years, there have been many approaches and many attempts to build AI systems. We can classify them very roughly. I am not giving a technical talk, so I'll try to give the intuition. The first classification is on the objective of the system. We have a narrow AI, as I said before, and general AI. Narrow AI, let me repeat, are systems capable of performing specific complex human functions, tailored for specific purposes. General AI, you build a machine that is like a human, thinks like a human, acts as like a human. Then there are different approaches to knowledge construction, because of course, all AI is based on different ways of representing the knowledge and reasoning on such a knowledge. what the humans do. We can roughly divide them in symbolic AI. Symbolic AI means that one tries to conceptualize the entire world in terms of symbolic structure. The system used to know this symbolic structure and is able to reason about it through operations on such symbols and to solve problems. You may think about ontologies, complex knowledge representation systems, and things like this to have an idea of a symbolic AI. Then there is a connectionist AI that is closer to machine learning, where intelligent decisions are based on a structure of interconnected nodes, the neural net, which simulate neurons and whose interactions grow with the new stimuli that are received during the life of the system. So connectionist AI is based on neural nets. Neural nets and connectionism are an old notion from the point of view of the research, in the sense that have been introduced tens of years ago, but now are very important and very much used. And we discover in a second why. Then last, we have another classification based on the way in which the system is built. In model-driven, the idea is that one may specify a model of the world through the classical activities of model specification: analysis, definition of knowledge, definition of rules, and so on. Then there is the data-driven approach, that again is the approach that is now very fashionable. The knowledge and the rules emerge from the data. The data that are collected on the phenomenon of interest. Of course, it's not a knowledge of the entire world. It's a knowledge of the phenomenon of interest. Then we can say that today, more than in the past, we have the narrow AI, let's say, I wouldn't say against, but sort of, in contrast, in comparison with what is called the cognitive computing. And we may say that the general AI didn't do much progresses, not in the last 10 years, at least. Also because in the last 10 years, a lot of research moved from general AI to machine learning, so to narrow AI. And so our poor machine that is trying to talk like a human and act like a human still has a lot of work to do. And another remark is the importance of creativity. No machine is creative. And no researcher knows how to have a creative machine. Nevertheless, AI is everywhere. You experiment artificial intelligence in the form of machine learning, when you pay something with your card, when you use sorry? You need to mute some microphone, I guess.
Yes, I've muted them. Tiziana, if there are, in case of questions in the chat, do you want to take them at the end? Or do you want us to interrupt you?
Depends on the kind of questions. I think in the end would be
okay.
Sort of easier.
Okay.
Okay.
Thank you.
Okay, so AI is everywhere. Face recognition, in general, image recognition. Image recognition is really the gold application for machine learning. Machine learning started to be successful exactly on image recognition. Then on natural language translation and by understanding. But you can see, so you experiment machine learning, even if you don't know that is machine learning, in every moment of your life. Now, what is machine learning? Well, while in logical reasoning, that again can be considered the traditional AI, the idea is that you define a procedure and the single steps that lead to the solution of a problem. You have a problem, so find the procedure, the steps, and get to the solution. Machine learning is very different because you start from examples of solutions and methods to generalize them. And this is also one of the reasons why it is specific, because you start from the examples of the solutions of the single specific problem. And of course, since there is always a devil somewhere, in our case, the devil is in the examples. And in particular, in machine learning, in this moment, what is mainly used is the so-called deep learning. Just a comment. Of course, where are the examples? The examples are in the data. Data, tons of data. Why machine learning that has been invented? Neural nets have been defined around 1947. Okay, 19, that's not a mistake. So, several years ago. Why this approach didn't work? Because we didn't have the data, didn't have the computational power that is necessary to process so many data, so huge amounts of data. So we are working on the basis of researches done 100 years ago, sort of, 80 years ago, but we now have computers and data. So data are the new oil. This is well known, it's a famous sentence, and it's true because everything is based on the availability of tons of data. Now, what is deep learning? Very, very intuitively. While Okay, all machine learning is based on the application of statistical methods on large amounts of data. In traditional machine learning, there is a lot of manual work done by humans to process the data and to extract the features that are then processed by the neural net. In deep learning, the discovery of the mapping of the representation is done by the net. So there is much less human work in pre-processing the raw data, but the representation and so the final result is not clear how could be generated. Why do we get that result? And this is probably one of the most critical problems of deep learning. Deep learning is not explainable to humans. You do not know why, or any human cannot understand why is getting that result. Just an example, you get an image of a turtle, the image is broken into pixels, then there are several layers of networks that at the end tell you that the image is a turtle. The problem is that you don't know how these networks work. And of course, deep learning does not do miracles. We do not have to move from the idea that machine learning is useless to the idea that machine learning can do everything. This is not the case. There are specific problems that can be solved very well by machine learning. However, deep learning requires huge quantities of data, doesn't easily deal with the hierarchical structures like taxonomies of concepts, isn't transparent, does not easily integrate with other types of knowledge, doesn't distinguish between correlation and causation, presupposes stable world because it doesn't adapt to changes. The answers are not always reliable, it's difficult to engineer, but mainly is not understandable by humans and propagate biases and discrimination often found in data because it generalized examples. And the examples are plenty of biases and discrimination. So correlation is not causation. This is one of the tons of strange examples that you may find on the web. There is a strict correlation between the US spending on science, space, and technology and the suicides by hanging, strangulation, and suffocation. Things that by common sense we may say that are not related. But if you give these data to an algorithm of machine learning, would conclude that are related. So what is done now, what one tends to do, the research is tending to do now, is augment human intelligence. Do not substitute humans with machines, not even in simple tasks, in case where these tasks have a social impact. And I show some examples. Why? Because the humans are much better at formulate questions and problems to solve, at doing common sense reasoning. So the reasoning we do every day, in every moment of our life, machines cannot reproduce. They have intuition and creativity. What is better at AI? Manage huge quantities of data, carry on pattern recognition in such data, and do statistical and probabilistic reasoning that, of course, we cannot do quickly, at least. So the idea is that humans and machines could better work together. And this is a simple example. If this is the error rate that has been found in the identification of metastatic breast cancer by top AI system, 7.5 error rate. As you can see, the human is better also in this. The pathologist, 3.5 error rate. If you combine top AI system and the pathologist, you reduce the risk of error to 0.5. So this is the right direction for using machine learning. Now, just let me spend, I know that I am out of time more or less, but 5 more minutes just showing some examples of what I said, why data are plenty of bias, are plenty of sexism, are plenty of racism, unfortunately. So we cannot trust the data. Just a very recent example. This Robert Julian Borchak Williams has been arrested because a facial recognition algorithm recognized him from the image of a surveillance camera, but was not him. And he said to the cops, "Do you think all black men look alike?" This is a recent famous mistake. Another very famous, one of the first one is the mistake done in criminal sentencing about the possibility of young people to stop carrying on criminal activities or not, and that there was a clear bias in the answers of the algorithm. Another famous case is the recognition of autism symptoms through facial analysis has been experimented in the United States. Unfortunately, the training data contain mainly images of Caucasian children. So the algorithm typically does not recognize the same traits in girls and boys who are not Caucasian, so excluding them from the care and support program. Damages that can derive from the complete automation of decision-making processes involving having a strong social impact. For instance, a machine may decide whether to give a mortgage or a credit to someone, and you do not know why he's saying yes, but more important, you do not understand why he's saying no. And also has been studied that the decision is based on discriminations that have nothing to do with the real the real parameters that have to be taken into account. When Google Translate converts from a sentence like this, is a nurse, she's a doctor, in another language without gender, for instance, Turkish, and then you translate again, then the nurse becomes a she, and the doctor becomes a he. Because in the data, there are more male doctors and female nurses. And gender biases are amplified by artificial intelligence, by machine learning, also because there aren't many female designers, female computer scientists working in machine learning and artificial intelligence algorithms. Less than 10% in the United States, and the rest of the world is not better. And these and other aspects are the work that is done in what is called ethics of AI, or AI and ethics. The ethical problem of AI is one of the most crucial nowadays, because we can use AI for good, but we can also use AI in a bad way, in such a way to amplify and propagate discrimination and biases. And why this come? Because you have to check, for instance, where do the data come from? The majority of data come from the United States. Look, remember that algorithms work generalizing examples. So if you have the majority of images from the United States, Great Britain, Italy, Canada, then your algorithm will recognize the bride on the left, but not the bride on the right, because that doesn't have enough images of an Indian bride. So bias in the data and bias in the algorithms. For instance, this algorithm that reconstruct faces is turning Obama into a white man. So what is that the community of the researchers is trying to do is now moving, after the enthusiasm for machine learning and so on, is now moving to doing research in what is called the AI for good, concentrating on AI ethics, human-centered and value-oriented design of technology. So the technology has to be human-centered. Social-minded measures. Data and algorithms have to be fair. They have to be without bias and take into account the diversity. Machine learning has to be transparent and interpretable, understandable by both the experts and the final user. So someone having rejected the request for a credit has to be able to understand the reason why the algorithm is rejecting such a request. And finally, there is a new research concentrating on AI and neurosciences, in which natural intelligence may enrich machine learning and AI by letting the researcher copy new learning mechanisms to be introduced, and the AI may produce prostheses to enhance or even repair in case of damages human capabilities. So the future is really AI for good. At least this is what we hope. Thank you. So now, okay, my talk is over. So let me see if there are questions. I don't know. Andrea,
I have a question in the chat.
Okay, yeah, just a minute, Fernanda, to thank.
Sorry.
Welcome. To thank Tiziana for this very clear and clarifying speech. I had my guess confirmed that most people talking about machine learning are not properly entitled to do that. And the point seems to me that people who really know machine, they know the limits, they know the bias, they know the problems related to machine when compared to human intelligence. The main point from my side, then we will go with the, if you have some time, Tiziana, we have some questions for you. From my side, the main point for the discussion is the fact that the way you consider artificial intelligence and the following classification basically depend on the way you consider human knowledge, which is a main point for us in order to understand the relation between journalism, creative, professional, content production, and machine. But maybe we'll save this part for the following discussion. And Fernanda, do you want to go with the questions? I don't know.
I can do it.
Cristina, come facciamo? Cristina, come facciamo?
First of all, I would like to welcome Professor Beckett, who has just joined the meeting. And yes, Fernanda, please, if there are questions in the chat room, you can read them, and then I see also hands raised.
We have hands raised and 2 questions in the chat. The first one is from Somaya. I guess, if I understood well, she wants to know which challenges artificial intelligence puts for online journalism.
Well, of course, the challenge is in the risk of propagating false news. Because the problem is that on one side, artificial intelligence provides journalists with a strong mechanism to analyze the information, the available information, to correlate, to do, I don't know, image matching, but you know there are also fakes on this. And to somehow automatically find and classify information. But on the other hand, there is the risk of taking the results of the algorithms and giving them for granted. Because again, one of the key problems nowadays with deep learning is that not even experts know exactly how certain conclusions have been obtained. So it is a sort of magic, just to simplify a little bit. But it's true. So the network is not transparent. So you do not know why. So you cannot judge if a certain correlation, for instance, between facts or news, why it has been derived. So you have to trust the algorithm. And of course, from the point of view of a journalist, I don't think that this is something reasonable, because again, the human can exploit the pre-processing, let's say, done by the algorithm, but cannot trust it entirely. You cannot rely only on the algorithm.
Okay, thank you. And then we have another question from Jean-Louis Zanet. He wants to know how far away we are from a proper implementation of general AE.
We don't know.
AI, sorry.
We don't know. We don't know how far we are. We don't even know today if it would ever be possible. Especially because in this moment, there is a lot of research on narrow AI because it works. So, which is one of the problems with the AI, that for tens of years, researchers were trying to obtain concrete results in general AI, okay? And they didn't succeed. I mean, there were great theoretical results, but nothing really concrete, nothing that you can use in everyday life. Then machine learning has been, you know, sort of found again, because machine learning existed since many years before. But it has been discovered again. And given the number of data to be used as examples, given the power of machines, because you need machines so powerful to be able to process enormous quantities of data in little time. Otherwise, nothing works. Okay? So, since people started seeing that machine learning works concretely, it works on image recognition, it works on translation of natural language, it works. So the research moved from general AI to narrow AI, a lot. I cannot say that everybody works on this, but a lot of researchers, a lot of industrial research is now on deep learning, machine learning, and these non-general AI. So we do not know. Maybe we will never get to general AI. Maybe HAL will never be true, will never be a reality, but we do not know. For sure, not in the next 20 years, for sure. So.
Okay, thank you. And then I will select another question because we have many, maybe too many. And Ibrahim Mohammed asks if you think that artificial intelligence will eliminate the presence of human in the content creation process.
No, I think no. A lot of people think no. The question is that the humans, as I said, what a lot of researchers are, the directions in which a lot of researchers are going is augmented intelligence, coupling human and machine. Because the content creation process is something that has to do with the human creativity, the human common sense, the human intuition, all characteristics that machines do not have.
Thank you. Maybe we have time for another question. Okay, it's
Maybe
sorry.
Jalal, I see that he raised the hand or wrote a question.
Yeah, who is that one? I can't see. But we have questions on the chat. So it's like,
I'm just going through Jalal's question, if I may, and then I would
Okay.
suggest to move to the next.
Plenty.
Yeah, please.
Fernanda, maybe we can save the questions related to journalism to the following, no?
It's fine.
We'll go with the last one.
It's okay. It's okay. So someone asks about the difference between electronic journalism and the concept of artificial intelligence, and the difference between deep learning and machine learning.
Okay, let me pick the second one because I think you will have someone more expert on specifically on journalism than I am. Machine learning, traditional machine learning is that at certain point I did show a slide. In traditional machine learning, you have a lot of work done by humans, data scientists, in order to extract what are called the features from raw data. So you have a lot of pre-processing of data. And you have basically a single layer of network, okay? In deep learning, one of the key differences is that the pre-processing is at least partially, because there are attempts to do it completely, but let's say at least partially, done by the network itself, by a different level of the network. So the data, the raw data, can be given to the network. There is a first phase of pre-processing, then the results are passed to several levels, other levels of the network. So it's a multi-layered process that in general may start from the raw data. Instead, in traditional machine learning, the process starts from feature vectors. So from raw data that have been largely reprocessed. Don't know if this, then there are of course also differences in terms of algorithms, but these are very technical. So what means this? That you have less human intervention, because the pre-processing of data is a very heavy job. It's long and taking time.
I don't know if we have time for another question.
I don't know. Maybe we can save some. We'll see. I don't want our next guest to wait too long. So Tiziana, thank you very much. I hope you'll stay with us, and I hope we'll have maybe a Q&A session in the very end, if possible. I don't know. Cristina will tell us something about our schedule. Yes, Tiziana.
I'm sorry, but I have to leave because I have another meeting here.
Yes, you told us. You should. I forgot. So thank you very much. Thank you for being with us, and I hope we'll stay.
Thank you. It was
thank you for your speech.
Interesting, and enjoy the rest of the seminars. Bye. Thank you.
Bye. Thank you.
Grazie, Cristina.
Cristina,